Dear viewer, today we are going to explain two geometrical pure units which are given by System International. One is Radian and the second is Steradian. Now first we define Radian. Suppose we have a circle. O is its center and R is its radius. Now we also consider that if A and B is an arc of that circle, let this AB arc makes an angle theta with center. If we increase the length of the arc, suppose the arc length is equal to AC from here to here, then the angle will also increases. Initially it was theta 1 and now let's suppose it is theta 2. This means that theta 2 is greater than theta 1, meaning that if we increase the arc length, the angle also increases. So we have a direct relation between arc length. Let's the length of arc is denoted by S. S is directly proportional to angle theta. Now here in case of radian, we put the constant of proportionality as radius of the circle and theta. This is the general equation for radian. What is the general equation that shows the relation between linear and circular displacement? Now we try to find out how many radians are there in a circle. As we know that for a complete circle, the arc length should be equal to circumference of the circle, which is equal to 2 pi r. Now we separate the radians. Radians theta is equal to S over r. This implies that total number of radian in a circle is equal to 2 pi r divided by r. This r will cancel with r, we will get 2 pi. So there are 2 pi radians in a circle. There are 2 pi radians in a circle. Now we again consider that how much degree a radian is. So for a complete circle or for complete circumference, we get C is equal to 360 degrees, and in case of radian there are 2 pi radian in a complete circle. So if we equate these two equations, we get 360 degree is equal to, these are radian, is equal to 2 pi radian. Now if we calculate 1 radian, we divide this on both sides by 2 pi. Here you will get 360 degree divided by 2 pi. Now in this way this will cancel with each, and you will get 1 radian is equal to 360 divided by 2 pi, which is equal to 57.3 degrees. So 1 radian is equal to 57.3 degree. Now we are going to define 1 radian. How much what radian is? As from equation 1 here we saw that S is equal to r theta. So if we separate theta, this we will get S over r. Now the angle will be 1 radian if arc S is equal to radius of the circle. This arc that we have already defined as A to B, this length should be equal to radius of the circle. This means that S should be equal to r. So if we put S is equal to r, then it is possible that we will get 1 radian. Definition: from this equation we can define 1 radian as the angle, it is a plane angle, okay, you should remember it's plane angle because it can be drawn in plane. The plane angle subtended by an arc at the center of a circle whose length is equal to the radius of that circle. Okay, this is the definition of 1 radian. You should know that too. 1 radian is the plane angle subtended by an arc. Here this is arc from here to here. This angle I'm talking about is θ1. The angle subtended at the center of a circle by an arc equal to the length of the radius of that circle, meaning that the arc length should be equal to the radius of that circle. In this case, this angle will be 1 radian. Okay, this was a brief discussion about radian. Now I'm going to explain steradian. Steradian is a solid angle. It is a solid angle, and it is subtended at the center of a circle of a sphere. So here in this case, let me consider first a sphere of radius r in 3-dimensional space. Suppose it is a sphere, and here is the angle subtended by an area over the circle. Let's suppose this small area is A, and this area should be equal to r square. Now if we increase this angle, I'm telling you about this is solid, the solid angle. It should be denoted by omega. The solid angle will be increased if we increase the surface area on the surface. So we can write it as the surface area of the sphere is directly proportional to the solid angle, meaning that if we increase the solid angle, we will get more surface area. So here for steradian we put the proportionality constant as r square, radius square. So this will give us a general equation of surface area which can be calculated in terms of steradian if radius of the sphere is known. Now we are going to find out how many steradian in a sphere, in a complete sphere. So we separate this steradian from this equation, we will get this thing. Now for a complete surface area of a sphere, we have 4 pi r square. This is the equation for the whole surface of the sphere. Now if you put this here in this equation 2, we will get 4 pi r square divided by r square. This r square will cancel with r square. We will get 4 pi steradian. So there are 4 pi steradians in a complete sphere. Now we are going to define a steradian. Definition. Steradian can be defined from the above equation. Let's suppose we have equation 2 as steradian is equal to surface area divided by r square. This will be equal to 1 steradian if this surface area is equal to r square. In this case we will get 1. So from this equation we can define steradian as the solid angle omega subtended at the center of a circle, at the center of a sphere by an area of the sphere equal to the square of the radius of that circle, radius of that sphere. Suppose we want to make a clear picture of this. Here is radius of the sphere, and here is the surface area. The smaller patch of surface area, which is equal to the square of the radius, and this area makes an angle with the center of the sphere. This solid angle will be 1 steradian, or in other words, the solid angle subtended at the center of a sphere by an area equal to the square of the radius of that sphere. then this will be 1 steradian angle. So this was a brief discussion of steradian and radian. Thanks for watching this video.